Alright, this video is about shock and about light and how light can exceed what it normally is sent out in its frequencies and go into what I'm going to call atomic white. And I'll show that coming up right now. Alright, according to my theory of angular momentum, you know, the particle vortex theory, where everyth's a particle, and because it spins, it creates a wave. So it looks like a particle wave, but it's really just a particle. Now, these are the energy levels that these particles have going out, and these are the frequencies, the actual physical distance that the wave is from peak to peak. Now, my contention is that Rodney Warren has been doing some experiments with lasers and slit experiments, and the architecture of the slit is literally, it's just two nails. And the fact that it's two nails, the architecture of that creates a Venturi type effect, which is exceeding these frequencies. So they're forcing the frequency to exceed what it is now. So, you know, here's the thing about light. Light is supposed to go 186,000 miles per second, and I'll take that. I can accept that. And it does change in different mediums, and I can accept that. And the other thing they say is that light, the frequency changes, not the speed. So let's say everything goes 186,000 miles per second, and the length of the wave, which is the spin, is different. If you went to this end of the spectrum, way to this end, if you went all the way to we are in Connecticut here in the United States at 60 cycle power, every cycle that comes out of the wall, peak to peak, is literally 3,000 miles long. So it's mind-boggling. And what we're dealing with here is this entire thing from here to here is only 400, 600, 700, 300 millimeters, 300 nanometers. 300 nanometers, that's like nothing. So we can only see this from here to here, and this from here goes out around the Earth about 1,000,000 times, and this over this way goes 500,000 times. This is insanity, how short these wavelengths can get. But my point is that the frequency here is, let's say it's 500, and it hits that set of nails, and it starts spinning those things because they have to accelerate to get through that slit. Too many of them all going at the same time, and it ends up pushing them out at a little over what they entered at. So I'm saying that is what the creation of atomic white is. It's not just because you get way out at the end there and you get some brilliant stuff. No, every one of these this is my estimation, has increased from its normal radiation. So instead of this being 500, it's down to, or 600, it's down to 200, 590 or something. You know what I'm getting at. It's not. It's in a range that it really, I don't think it's not allowed in molecular, you know, in molecule arrangements, just not allowed. Now, but I'm not sure of that either. But I have seen this atomic white in these atomic sinkholes, and I'm going to show you one of those, and in what Rodney is putting out. And it's not just white, it's just white. This is atomic white. This is that glowing white that, you know, it just sears your eyes, really. I mean, it's a very, very appealing color, but it is, well, color, it's a very appealing shade of white, but it's out there. All right, and that's my impression. So many radiations. Anyway, that's my impression. All right, here's another thing that I want to point out. Is it, you see hydrogen down here? That baby's got all kinds of action going on here. Now, everybody thinks, oh, it can just shoot out this way. No, it can do shock, 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 shock. When you radiate out of here at enormous energies, it might hit one of these and blow it out. It might hit one of those and blow it out. It might one of these. So you're not just dealing with from here up. You could be dealing from here up and here up. So these, if they are accelerated, I believe, or if they are in a shock condition, they will create these additional shocks. And that's when you get this atomic radiation white. That's my theory. All right, all this research I've been doing is a result of sinkholes. And I've been studying sinkholes, and this is a fiery collapse of a sinkhole. They have biodigesters in there. Sinkholes aren't just holes in the ground, they're biodigesters. And what's inside here is bioorganic material which creates hydrogens and methanes and all that business. Those are atomic chemicals, molecules. And when they ignite they do this. That's not a birthday candle there. That is atomic white. That's my new name for that. When you see this kind of a glow, that's atomic white. All right, once again, atomic white. This is atomic energy, and it's being slowed down. The electrons and the neutrons, protons, whatever's coming out of this reaction is being slowed down by the water, and heavy water, and that sort of stuff. And the water is extremely dense. Extremely dense. Hydrogen, oxygen, case closed. A lot of protons. Anyway, this is atomic white, and it's a result of Cherenkov radiation, and it's a result of energies that are exceeding what they're allowed to go at. And the result is that they're going fast, they hit the water, and that is the thing that says you can't go that fast, and you get up this, that's when you get this shock stuff. Okay, now watch this video. And the thing I want you to watch about it is it's just completely obvious that it's real. And they saw some silly thing here, and and I'm thinking to myself, oh, this is going to be nothing. But watch. Now, what I want you to focus in on is the brightness of the white of the object that you will see shortly. The brightness of it. All right, and check, this is really very, very interesting. This came off of Larry Gerndt. Look at the white now. Look at how brilliant white that is. Whoa, did you see that thing? Now watch these things. Very cool. Now these are atomic white colors. You know, atomic white, I believe, is something that has a higher energy state than is really we see. Now watch this thing go. Gone. Very, very interesting. But look at how brilliantly white that is. That's one of the things that just struck me, because that is, I'm saying that is atomic white. That's atomic shock white.